I am Anil Kumar. Let me thank all the members of our WhatsApp group, Free Math Solution, for participating actively. Many of us are working to provide solutions, and we are having brilliant questions from some students. Many students are joined in to provide excellent solutions also. Here is a perfect example of the same. So we have a question here based on geometry, tangents to a circle, whose solution was provided by Krishnanjan, a grade 11 student. So I'm going to share with you the solution provided and also provide you with some tips so that if you are preparing for a multiple choice test paper, you will be in a position to answer such questions within a minute. Now that is kind of important for many of our participants since they are preparing for competitive exams. Perfect. So let's take the question. It is tangent AB and AC are drawn to a circle from a point A such that angle BAC is 40 degrees. So we are given this angle BAC as 40 degrees. A chord CP is drawn parallel to BA. So this is parallel to BA, right? So let's call this point as Q. Find the measure of angle CPB. So what is that angle? CPB. So let's join CBP, right? So we have to find this angle. Let me join P with B. And we want to find what this angle is. That is the equation. Perfect. Now, you can always pause the video, answer this question, and then look into my suggestions. Now, before getting into the solution of this question, I want to take another related question. We'll use many concepts which we are going to see in the related question about tangents to a circle, right? And then get back to this. Perfect. So let me take a related question here. So I've kept almost everything same. So now my question here is, tangent AB and AC are drawn to a circle with center O from an external point A, right? So again, we have an external point A. We need to show that angle BAC, so angle BAC is this angle, right, is twice angle OBC, is 2 times angle OBC, this small angle. So the relation between these two is that angle OBC is equal to this angle, is equal to, you can say, twice this angle is equal to angle BAC. That is what we need to prove. Clear? Now, let us look into this proof first. Now, there are a couple of important things which we'll get from here. One of them is this. As you note that this angle is 90 degrees, correct? These two angles are 90 degrees, right? So these are angles with tangent with radius. Right? So both these angles are 90 degrees. That means what? In the quadrilateral, so in quadrilateral, this angle, which is angle BOC plus angle BAC should be equal to 180 degrees, correct? Since these two are 90 plus 90, 180, those two should be also 180, right? Correct? So those two are 180, right? So that actually helps you to understand one more important thing, and that is, we can say that, so note, we are going to use this in our solution. That's why I'm writing this note, that the angle BOC is basically equal to 180 degrees minus angle BAC. So that is one thing which we are going to use in our discussion, right? You should know this. Okay. Now another thing, we have to really find this relation, right? Since we have an isosceles triangle, the angles at OBC and OCB both are equal, correct? So these angles both are equal. So if this is x, the other one is also x, correct? So from here, in the triangle OBC, what do you see? You see that 2x, sum of these two angles, plus angle BOC is equal to 180 degrees. Is that clear? All right. So 2x plus that angle is equal to 180 degrees. But that angle is this angle, right? So if I combine these two statements, where I'm saying what? That 180 degrees is equal to BOC plus BAC, right? And 180 degrees is also equals to BOC plus 2x. That means what? That means that I can write this as 2x plus angle BOC is equal to angle BOC plus angle BAC, right? Clearly, 2x is equal to angle BAC, right? So 2x means 2 times angle OBC, right? So we just in short use the word x. So that is kind of important to understand, right? So we learned two things. That is, one, that the angle O is actually 180 minus that angle. And the second thing we note is that angle OBC is equal to half of angle BAC. Is that clear? So these two things we are going to use in our solution. Perfect. Now let's get back to the equation, correct? So now let's continue with our solution. So what we'll do here is we'll connect the point B and C with the center O, right? So let's say that is the center O. So we are going to connect B with O and also C with O. So we have center O now. So what did we learn? We learned two things. One is that this particular angle OBC, this particular angle OBC is half of 40, right? So we learned that angle OBC is half of angle BAC, which is half of 40 degrees, which is 20 degrees. Is that clear to you, right? So this angle here is 20 degrees. Is that clear? Second thing which we learned is that angle BOC is 180 degrees minus BAC, which is 180 degrees minus 40 or 140 degrees. So this angle here is 140. Clear? Third thing, that is at the center, so what will be this angle? So that means that the angle BPC is actually half of 140, right? Is half of the angle at the center, angle BOC, which is half of 140 degrees, which is 70 degrees. Is that clear? So this angle is 70 degrees. You get it? Now, we are given these are parallel. We are given that these two sides are parallel, right? So do you see a Z pattern formed here? So that means this angle should also be 70. Correct? So that means that the angle QBP is also equal to 70 degrees. So we have alternate angles. Correct? What do we need to find? We need to find that angle. So total we need to find. But well, we know this is tangent, right? So that is 90 degrees. So we know that the angle QBO is 90, right? So we can say that the angle OBP should be equal to angle OBQ minus angle PBQ, which is 90 degrees minus 70 degrees, which is 20 degrees. Is that clear? So this angle is also 20 degrees. Got it? What do we need to figure out? What is angle CBP? So CBP is the big angle which we really want to find, right? That angle. Sum of these two, which is 20 plus 20, right? So CBP is equal to sum of angles CBO plus OBP, which is 20 plus 20 degrees, okay, which is equals to 40 degrees. Is that clear to you? Correct? So we get this required angle as, so our answer here is 40 degrees. Is that clear? So that is how we can actually answer this question. So it's important to note a couple of things. When you have a tangents from an external point, those are 90 degrees, and therefore sum of these two will be 180 degrees. And the angle formed by another point on the circle will be half of that, 70 degrees. Also note that the angle which the chord makes with the radius is half of that angle which the external tangents make. Now that's a very important theorem. So it is half of that, which is 20. Now, using the Z pattern, since we are given these two are parallel lines, we could find the other angle as 20 and their sum is 40, and that becomes our solution. So I hope the steps are absolutely clear. Now, let me once again thank you all for providing these brilliant solutions, and I hope many of us can join together to provide solutions to the persons who really need them. Feel free to join our group. The link is being provided. And thanks for your contributions. All the best.